Welcome to the Science for Alaska lecture series. Today's episode, Whale Watchers, Novel Uses for Unmanned Aircraft. I'm Cathy Cahill. I am the director of the Alaska Center for Unmanned Aircraft Systems Integration at the Geophysical Institute at the University of Alaska Fairbanks. I'm here today to introduce you to the concept of unmanned aircraft and the types of missions that we are doing to help preserve endangered species using this novel technique. So, unmanned aircraft systems. You more commonly hear them referred to as drones. We don't like the term drones. The term drone implies there's no intelligence. When we're flying an unmanned aircraft, we always have a pilot in the loop. So, in terms of unmanned aircraft, the University of Alaska has been doing this since about 2001. We started out at the Poker Flat Research Range, and we have grown since then. And in 2012, the Board of Regents formed us into a center. So the Alaska Center for Unmanned Aircraft Systems Integration, also known as ACUASI, is the University of Alaska's Center of Excellence for Unmanned Aircraft Systems. We have three key missions that we're focused on. The first one is assisting the FAA with the safe integration of our unmanned aircraft system into the National Airspace System. We already have a bunch of planes in the atmosphere. We are adding new planes that do not have pilots on board to an already existing system. So our goal is to help ensure that that is safe, that there's never a collision between an unmanned and a manned aircraft. We're developing the tools and technologies to ensure that there is never a collision. We are also supporting Alaskan and Arctic users. These are people who want to use unmanned aircraft to do things like monitoring pipelines, counting walrus or moose, doing flare stack inspections up on the North Slope. Things that are hazardous, but that could be done with unmanned aircraft far more safely. We're also looking at things like how do you deliver medical supplies to remote communities. So there's a wide range of opportunities here for unmanned aircraft operations in Alaska in support of Alaskans. And of course, we're part of the university. So we have a long, rich history of scientific research. And a lot of what we're focused on is how do we do that research safely? How do we get data that we otherwise cannot get? And how do we go ahead and move science forward using this novel technology? Overall, our goal is the complete integration of unmanned aircraft systems and manned aircraft in the National Airspace System. This particular picture is our pilot, Matt Westhoff, and our SeaHunter in Nunavut, Canada. Our aircraft will be flying off of the exact same runway as you see that cargo aircraft landing on. So that would be a complete integration. We're operating off the same airports exactly the same way as the current aircraft that are operating. So who is this weird bunch trying to do this? We're fun. We're a group of veterans and former defense contractors, science engineering faculty, staff, and students, and pilots. Of course, if you're flying an unmanned aircraft, you need to have pilots. All of our pilots are also manned aircraft pilots. They understand aviation. They're used to working with the FAA. We have aircraft mechanics. We've got business developers. We have somebody who specializes in talking to the FAA to help get us the permissions to fly. So overall, we're a very unique team. And we're doing some unique work. We're working with Transport Canada to actually help them develop the rules and regulations, policies, and procedures for flying unmanned aircraft in the Canadian airspace system. So Transport Canada deals with the rules and regulations for transportation, kind of like our FAA does. The Aircraft Services Directorate is specifically focused on aviation rules and regulations. Inside of that, there's a directorate, the Remotely Piloted Aircraft System Project, RPAS, Remotely Piloted Aircraft System. Little different from unmanned aircraft, just by name. In this particular case, internationally, people use RPAS instead of unmanned aircraft. It's the same thing. They have a mission to patrol the northern borders and ensure that people are not poaching, they're not doing illegal fishing, they're provided for search and rescue so they can help people if there's ever a problem. And we are helping them work on how you can use an unmanned aircraft flying out of normal commercial airports to achieve these purposes. So how did we get tied up with Transport Canada? Well, if you search Arctic and unmanned, you don't have many options for people with experience and a fairly large aircraft. That would be us. That would be ACUASI. ACUASI brings expertise, and we bring an aircraft that we can use as a test aircraft for them. So I'm going to introduce you now to Andrew Wentworth, who happens to be one of our excellent pilots and was the program manager for the mission for Transport Canada last summer. And I'm going to let him tell you our story. Andrew?
Thank you for that warm welcome, Kathy. My name is Andrew Wentworth. I'm an RPAS or UAS pilot. You could even use the term unmanned aviator. I'm currently serving as the program manager for the SeaHunter program with ACUASI. Before we get down to the meat and potatoes of the presentation, I'd like to go over some unmanned aircraft systems or UAS etiquette. So I want you all to picture this. It's early morning, pre-flight. Temperatures are just below 0 degrees Fahrenheit. And we've got 2 crew members inside of a heated trailer with computers and mice and dry erase boards and all manner of radio equipment. We've got 2 crew members outside in mittens and hats, also on a headset, dealing with the ground support equipment in the aircraft. And inside this warm heated trailer, while over headset with everyone, one fellow turns to the other one and says, "Hey, there's a draft underneath this desk and it's kind of cold in here or warm in here. Do you think you could change the settings on the heater?" And all we could hear from the other end of the headsets, from the guys outside, was some, shall we say, entertaining language, as they were displeased with our complaining about the environmental control in the trailer. So, going forward, if you ever happen to find yourself involved in a UAS activity, you're in the trailer, don't complain about the heat when people on headset are in the cold. Vice versa, if it's in the middle of the summer and you've got air conditioning in the trailer, don't complain about how cold the air conditioning is to the people on headset who are outside and are sweating to death. So the beginning of the relationship between ACUASI and the RPAS Project Office in Transport Canada started in 2017 or so, and here is a video that Transport Canada produced when the program started. So the program started in 2017-2016 timeframe or collaboration. It has since matured, and here's a video Transport Canada has produced that is dated January of 2020, so just over a year old now. You'll see in this that we are no longer a candidate. We are actually now part of their National Aerial Surveillance Program, and we are now doing the patrolling the marine habitats and activity. And towards the end of the video, it mentions North Atlantic right whales in the Gulf of St. Lawrence. And that is what the remainder of this presentation is all about.
Transport Canada is leading the way with the integration of large remotely piloted aircraft systems, or drones, into Canadian airspace. Aircraft Services Directorate is conducting drone missions to develop beyond visual line of sight regulations for Canada. We work closely with Transport Canada regulators, NAV Canada, and air operators to safely integrate drones into busy airport operations. We've conducted drone missions off a Canadian Coast Guard icebreaker. We've mapped infrastructures and Arctic highways from the Yukon border to Tuktoyaktuk. We've conducted surveys for beluga whales in the Arctic Ocean and North Atlantic right whales in the Gulf of St. Lawrence. We're using artificial intelligence to identify endangered marine mammals. Transport Canada is bringing drone technology into the future of aviation in Canada.
So what are we looking for here? The North Atlantic right whale is an endangered species. Most recent estimates are there are about 400 individuals alive on the planet, and recently We've had 31 confirmed deaths since 2017, and we've had 12 serious injuries, which are defined as likely to lead to death, but not yet confirmed. As typical for whales, they calve in southern waters during the winter and then feed in northern waters during the summer. Why is this called the right whale? Well, it is very docile in nature, so it doesn't put up a lot of a fight. It's slow moving and it skims the surface during its feeding, and it remains close to the coastline during the feeding iterations. These make it easy to get to for whalers and hunters. Also, it has an extraordinarily high blubber content, meaning that when they're killed, they float. Also, the whalers get an inordinate return on their investment. They have a large oil production out of each whale, making this the right whale or correct whale for the whalers and hunters to target. So we've got an endangered whale, but what's the problem? Well, the whales used to be in the Bay of Fundy in the Gulf of Maine during the summer, as indicated here on the map. Now they're in the Gulf of St. Lawrence, as also indicated on the map. Now, why the relocation? So the consensus amongst biologists and climatologists is that they're chasing the food supply. And the supply of copepods and krill that they eat has moved from the Gulf of Maine into the Gulf of St. Lawrence. Well, that's not such a big deal, a whale species chasing its prey from one location to another, but the Gulf of St. Lawrence, comparatively speaking, is far busier than the Gulf of Maine. In the Gulf of St. Lawrence, we have shipping lanes that supply Quebec City, Montreal, and the entire Great Lakes region. So let's think about that. We've got Buffalo, Niagara, Cleveland, Detroit, Chicago, Duluth, Thunder Bay. When you say the entire Great Lakes region, that's a huge portion of the American populace, and the bulk of the Canadian populace on the eastern seaboard is along that waterway. That creates a problem. So now we have an endangered species that's cohabitating or in the same location as high volume shipping traffic, setting up a recipe for disaster. So we have a large number of vessel strikes, and they have had whales wash ashore, and the biologists have done necropsies and determined that the leading cause of death of this endangered whale are vessel strikes. That is something that we would like to prevent. So there's an international effort going on to preserve the species through all seasons of the year. So what's the traditional solution for this particular dilemma? So the manned aircraft with marine mammal observers, or MMOs, will fly through the shipping lanes. These MMOs are specifically trained to recognize the species of the whale, and they also are specialist biologists in many cases. So the manned aircraft will fly through the shipping lanes. You can see a map of their flight path in the upper right-hand corner. While flying along these routes, they will have the MMOs looking out the side windows of the aircraft with an oblique field of view, and they're looking for the whales, and they say they can see the whales as much as a mile or more out. The problem, though, is they're looking at obliques. They can only see when the whales surface or when the whales have a blow. If the whale surfaces or they spot a whale, they can direct the aircrew to fly over to that location and orbit the whale. You can see on that map of their flight path several whale spottings and the corresponding flight paths where they circled where the whale was seen. If the whale that is spotted is a North Atlantic right whale, they can radio it in, and the Transport Canada will introduce speed limits on the shipping lanes. And that causes a problem, actually, because all the shipping vessels that go through those lanes don't have to, but would like to very much operate at their efficient speed. Any slower and they're burning more fuel than they need to, and any faster and they're burning more fuel than they need to. So when Transport Canada introduces speed limits in these shipping zones, all of a sudden these shipping companies are burning money trying to get where they're going at a slower rate. So what does ACUASI bring to the table? We're bringing the SeaHunter unmanned aircraft to the table. The SeaHunter is manufactured by Griffin Aerospace in Huntsville, Alabama. It weighs about 300 pounds and has a carbon fiber airframe. It has two engines. They're each 150cc two-stroke fuel-injected engines. You can think of these one of two ways. They're either very fancy model aircraft engines, or they're very fancy chainsaw engines. Either way, same result. It has a retractable and steerable landing gear, has brakes and flaps, and he uses the Piccolo avionics suite, which is fairly ubiquitous in UAS of this size. Has an endurance of 9.7 hours. With that comes a certain understanding. When we flew for 9.7 hours, we had fuel remaining and time remaining in the day, but the crew, we were tired. We didn't want to be there anymore. So we run out of attention span before the plane runs out of fuel. We've flown it to 15,000 feet. It's our altitude ceiling. However, these missions on the Whale don't require that altitude. The data link range. We can go 70 miles with a radio link and an unlimited amount of miles on our satellite link, meaning that it is possible to fly this aircraft in the Gulf of St. Lawrence from Fairbanks, Alaska. So let's have a look at some of these pictures we've got. On the top, we have both of the aircraft partially disassembled for transport. They'll go into the back of that trailer. Next picture down, we have our trailer with our antenna array on the roof, and in the front portion of that trailer, we have essentially the cockpit or control station where the flight crew sits for the duration of the flight. Below that, we have some glamour shots of the aircraft in front of the terminal and gas bay, and some pictures of our ground crew. One of the benefits of SeaHunter is that it's relatively fast for a UAS. Most UAS of this size are kind of slow. SeaHunter cruises about 80 knots, or 92 miles an hour, meaning that over the course of an 8 or 9 hour mission, we can cover a large amount of land that is useful for these missions where we're covering the Gulf of St. Lawrence. So who flies this thing, and how many people does it take to fly the SeaHunter? Well, it takes 5 of us. The internal pilot, or PIC, that happens to be me. I'm there in the center picture with the glamour shot with the aircraft. Takes a supplemental pilot. He's there on the bottom right giving us the thumbs up, and you can notice the seat that's empty next to him. That would be my seat, but I'm the one taking the picture, so obviously I'm not in it, which is why you'll see a lot of these pictures without me in them. On the top right, we have our external pilot. He's our safety pilot. He has a hand controller in his hands. He's on a headset, and he's talking to the people inside the trailer, and the aircraft's on the takeoff roll right there. On the bottom left, we have our ground crew. Fellow with the sunglasses smiling at the camera. He can fix anything. If it's broke, he can fix it. Wiring, engines, airframe, trailer, generator, truck. He is a one-stop, one-show handyman. Couldn't do it without him. Last person, our payload specialist. He's down there with a laptop connected to the payload, configuring the payload. Without him, an argument could easily be made that there's no point in flying. If you're flying a UAS without a payload, you're not collecting imagery, you're not collecting intelligence, you're not doing a useful job other than burning gas or, as we say, burning holes in the sky. Altogether, these 5 individuals have over 70 years of combined UAS experience. And that is one of the reasons Transport Canada has brought us on board for their RPAS efforts. Our solution in 2018 was a proof of concept mission where we deployed the SeaHunter system and the team to the Gaspé Peninsula. The objective was to verify whether or not we could use a UAS with a camera to do the same or similar mission to the manned aircraft. One of the key threshold objectives was, could we determine the species of the whales we were seeing with the camera? Turns out we can. We tried 2 cameras in 2018. We had a Sony NEX7 that was 24 megapixels, and then we had a full motion video camera that had been converted to take stills. Both of these cameras operated in either on or off feature, as in they started taking pictures as soon as we turned them on the ground. So they were taking pictures before we ever took off, all the way out to the whale area, all the way back, and they didn't get turned off until after we had landed. So we were getting a lot of pictures of runway, trees, land, people's houses en route. We would take off, and what we would say, we'd call it mowing the lawn. So we'd go out and we'd mow the lawn or fly transects for hours out over the Gulf of St. Lawrence looking for whales. And after we'd land, at the end of the day, we'd download thousands of pictures. You can do the math yourself. If we're taking a picture every second, and we're flying for 5, 6, 7, 8, or 9 hours at 1 picture a second, that is a lot of pictures. On a 24 megapixel camera, that's a fair amount of data. So we'd have to download these pictures. That takes some time with that amount of data. We would then take those pictures and run them through an artificial intelligence software package manufactured by Planck Aerosystems. This was a training aspect. We're training the artificial intelligence to recognize whales. Took some time and several iterations during this first season, but we finally got this AI relatively good this first season. The AI divides each picture into keypads or chips so that it can take each picture and break it down into manageable portions before it runs it through the algorithm. After this is done, the marine mammal observers would review all the pictures. They do a quality control check on the AI to say, did it miss anything? Did it find something that isn't actually a whale, it's a wave or some other anomaly? This created data management problems and led to at least 48 hours from the time the camera saw the whale. It was 48 hours before we could run it through the AI, download it, run it through the AI, have the MMOs proof everything, and then communicate the data outside of the team. We're looking at 48 hours. That was not ideal. Now, it's important to understand the difference between the allure of the Save the Whales mission and the reality. When you tell your friends or coworkers or family members that I'm going to Eastern Canada and I'm going to participate in the Save the Whales program, everyone imagines this grand scheme where a klaxon or alarm goes off and we jump out of bunks and we're all perfectly tanned and wearing these amazing swimsuits. We're dashing across the beach to save the stranded whale. It's very Baywatch, everyone's fantasy. That's a fantasy. That's not the way Save the Whale missions are, or at least this one. They're long days, staring at computer screens, doing a lot of nothing, usually very dull. That's the way UAS operations are supposed to be, and that's the way we like them. So here's an image of the reality of this kind of mission. On the broad scale, we have one of the images out of the camera. We are asking our marine mammal observers to look at thousands, tens of thousands of these on a daily basis and try to spot the whale. You can see what a whale looks like in the big scale picture. When we zoom in on this one little tiny blip in the corner of the picture, we can see a whale. That's what the AI is doing for us. The AI is looking at this big picture and finding that whale for us. So during the off season, in 2018 and 2019, we undertook a series of payload development efforts. One of the things we learned is that the manned aircraft had a Nikon D850 camera, which is a 45 megapixel camera on board. And when they spotted a whale, they'd get pictures of it for the biologists. We wanted to create more equity or apples to apples with the manned version of this mission. So we took that camera and put it into the SeaHunter. However, it has 45 megapixels as opposed to 24 megapixels, meaning that all of those pictures are more data, and you can do one of two things with that extra data. You can get better resolution on the surface of the ocean, or you can get more coverage with the same resolution. Part of this camera upgrade involved making the camera automatically controlled and remotely controlled. So beforehand, the camera was on, off, and it just went on its merry way through the whole mission. This design was that we could start and stop the camera. We could get status heartbeat messages out of the camera while we were flying it. These techniques allowed us to reduce the image count. So we're no longer taking one picture a second as we transit out to the area. We've got the camera sleeping as we go out to the interest area. When we get out to the interest area, then we turn the camera on and we start taking pictures. That reduced the image count and minimized the data management issues we were having beforehand. We also are able to control the camera over an Iridium radio link. This accelerates our post-processing efforts and alleviates the data storage problems that I mentioned earlier. The Planck Arrow, who does the artificial intelligence software, which is called OpTrack, their software now had to handle pictures that were twice as big from a data perspective. So it wasn't just a throw a different camera in there, it was the AI algorithm had to be changed. The modules that now controlled the camera had to be upgraded, and we had to train the algorithm again with another set of data. Large undertaking. So in 2019, we went back to Gas Bay with our new improved camera. We were developing the concept. First year was just, can we do this? Now let's see if we can do this better. So new camera, we'd go out, we'd fly 4 hours, mowing the lawn as we call it. And after landing, we'd download thousands of pictures. However, fewer pictures than the year before because we'd been able to selectively activate the camera. But each picture was more data than the year before, so it was essentially the same amount of data in some way, shape, or form. We'd run these thousands of pictures through the artificial intelligence software package, take a couple hours to process, and then it would spit out all of the hits. The marine mammal observers would review all of the hits and all of the raw pictures to make sure nothing was missed. This resulted in much as the same year beforehand, a 48-hour decision-making loop between when the camera saw a whale and we were confident and it had been quality control checked by a MMO that we could report that whale up to the Ocean Protection Plan. There were some hiccups that year. We had some reliability considerations with the aircraft, the payload, and the control station. We had some traffic conflictions with other aircraft operating out of the airport who had priority to be where and when. And if you didn't know, that summer there was a Hurricane Dorian. Hurricane Dorian blew up the East Coast and right into the Gulf of St. Lawrence. That weekend, when we weren't flying because of the hurricane, I saw a propane grill fly across the front yard. It was a good storm, especially for Atlantic provinces in Canada. On the pictures, we have an image of SeaHunter taking off en route to one of her missions. And then we have a picture of our flight tracks during the season in 2019. We would fly east out of Gaspé and then turn south and spend the bulk of our time in what is called the aggregation area. So we were looking to go where we knew the whales were to exercise, improve, and test the software and the payload. And lastly, the image here is of incredible importance. This is a whale that the standard manned solution would never have seen. This is a subsurface whale. And in fact, a marine mammal observer would have almost never seen this whale either. But the artificial intelligence was able to pick it out and highlight it for us. That means that our solution can find more whales, or more difficult to find whales, than the other solution. That's a thumbs up for us. Well, because we had those hiccups during the off-season in 2019-2020, we had a mandate from Transport Canada and a corrective action plan to address some of those concerns and as well as make things better. It's not just enough to fix a couple of problems. You've always got to go for continuous improvement. So on the drive home from Gaspé at the end of 2019, which is a very long drive, we sat there and brainstormed. We could do this, we could do that. No, what about this? Oh, that wouldn't work, so on and so forth. And we came up with a pretty good plan. But by the end of that drive, we wanted to talk about anything else other than the corrective action plan and how we were going to move forward and correct these hiccups. End result, we did several things to improve the reliability of the system. We have an entirely new fuel system on board the aircraft, new pumps, bladders, so on and so forth. We improved our satellite communications on both the aircraft and the control station. We did a wiring cleanup on the aircraft. It had been bothering us for some time. We finally got in there and got rid of some extraneous wiring and consolidated some things, and we were able to drop between 3 and 5 pounds out of each airplane in excess wiring. We also optimized our transponders configuration. Now, another facet of this corrective action plan is they wanted the payload to be better. And one of the things they wanted the payload to do was they wanted the artificial intelligence to be running real time on board the aircraft in flight. That took a bit of doing. And we wanted real-time notifications. So when the AI picked up on a whale, we got a text message from the airplane saying, I saw a thing at this location. When we're within radio line of sight around the airport, we can look at the chips, we can look at the full-scale images over the link with the aircraft, and we can confirm, yes, a North Atlantic right whale, not a whale, so on and so forth. Part of this is we're going from concept development, proof of concept. Now we're anticipating we're going to go to a fully operational mission. Transport Canada wanted policies and procedures improved and testing and training improved. And that's completely understandable given that we were moving from an experiment to an operational mission. In the middle of this, in the spring of 2019, the winter of 2019, the pandemic struck. That involved coordinating part delays for the refit, moving to a telecommunicating business presence to work on the corrective action plan, and travel to the test site so that we could test all of our modifications, fly and train ourselves on the new configuration before we went to Gaspé in 2020. In the pictures, on the top left, we have the ground crew with the aircraft doing some fuel testing. On the top right, we have our 3 engineers in the engineering lab at UAF. They did an amazing job getting the payload to work. On the bottom right, we have an image of the computer that is now on board the aircraft as part of the payload that processes these images real time. On the bottom left, we are working on the aircraft out at the airport after a flight one day. It was a bit warm there that day, so we put up the awning to enjoy the shade. So, our solution in 2020, we went back to Gaspé for our first operational mission. So we're no longer a science experiment. This is the real deal. The artificial intelligence is now in the aircraft. We're getting notified real time of any time the payload spots something. The AI is able to process the pictures at the same speed that the camera's taking them, so we can keep up. So there's no backlog being created. Mission profile is more or less the same. We take off and we mow the lawn for many hours. If we're within radio line of sight, we can look at the raw images and the chips and assess them ourselves. And if we have an MMO in the control station with us, they can assess the species of the whale. Every flight, before landing, when we're coming back to the airfield and we come back into radio line of sight, we can examine all the chips, download them, and we can start decision making for what's to fly next, where the whales are right then in flight. So for the last 2 seasons, it had been a 48-hour decision-making loop. Now it's an in-flight decision-making loop. However, there's an asterisk there. After we landed, we still downloaded all the pictures, but the MMO still needed to quality control check the AI and all the pictures. So it would take them some amount of time to run through the pictures. But as with anything, the more you do it, the better you get at it. You get a technique. They were able to QC the pictures that night, so the next morning we could submit our findings. Over the entire course of the 2020 flying season, the AI didn't miss any whales. However, we didn't see any North Atlantic right whales in the shipping lanes. We saw plenty of other whales, plenty of other things that are whale-like, but we didn't see any North Atlantic right whales. Good thing, bad thing, depending on which side of the equation you're on. I mean, that means the North Atlantic right whales aren't there, but that means the shipping lanes were slowed down because of something we found. This flight campaign was the most successful ACUASI mission to date. That's something. It was stress-free. It was relaxing. It was almost like UAS summer camp in Quebec. Everyone was smiles and it went smoothly. On our pictures, on the top left picture, we have pictures of our flight tracks. And you can see that we went through the 2 shipping lanes. Those shipping lanes are called Alpha and Bravo. We did those multiple times. And the UAS, you can fly the same flight back to back. So even though it looks like one set of lines, that's multiple flights flying the same set of lines. On the top right-hand corner, we have all of the whales we saw. And you can see a lot of them are right off the east coast, right there in Gaspé, and some of them are up in the shipping lane. None of them are North Atlantic right whales, unfortunately. Below that, we have 2 of the identified whales that the software picked up with the green box surrounding them, indicating what we're looking at with the camera. Important to note again that this mission was pulled off in the middle of the pandemic. That involved interstate travel, international travel, and interprovincial travel. It involved numerous and copious COVID tests before, during, and after the mission. All in all, it was an amazing success despite those difficulties. So RPAS are not currently an equal user of the airspace, and maybe they never will be, nor should they ever be. So the analogy I like to run with is out on the highway, you've got automobiles and you've got motorcycles. And we understand that they're both motor vehicles and you ought to treat them the same, but every motorcyclist knows that the cars aren't going to get out of your way. You've got to keep your head on a swivel. You've got to be proactive about avoiding everyone else, as they aren't going to avoid you. I think the same mentality applies for unmanned aviation. We went out of our way to get out of everyone else's way, even though it should have been a cooperative effort and we should have give and take occasionally either direction. No, we always yielded to everyone else, and it worked out well for us. Something else, our presence led to familiarity and led to comfort. So in the first year, this might be a bit of hyperbole, the manned mission on the whale side, if we were flying, they wouldn't even take off the ground in Moncton, and we're in Gaspé, hundreds of miles apart. So, it felt like if we were airborne in this hemisphere of the planet, they wouldn't bother getting off the ground. They were that afraid of us. The next year, we told them we were flying, and they said, we're going to go check it out. So they flew out to where we were operating and flew above us and filmed us with their camera on board their aircraft. And air-to-air footage from manned aircraft to an unmanned aircraft is on one of the videos from previous in the presentation from Transport Canada. Back to 2020, now they're comfortable. So we were deconflicting on a daily basis. We'll go here this time at these altitudes and they'll be here. And essentially neither operation impacted the other, so we were able to communicate effectively back and forth. Now there is some fear of replacement here. That's understandable, and that leads to reticence. Do they really want to encourage us? Or are they going to try to stonewall us in our mission? We've got to get rid of that and come to a one team, one fight kind of thought place. Now, part of the ACUASI's mission and purpose is to foster a public understanding of UAS. So you can't be cold or non-receptive. You've got to proactively go out and talk to everyone else. So every time a new aircraft landed at that airport while we were operating, we had someone designated. They'd go over there and they'd talk to the pilot and the co-pilot and the passengers, and it's all about shaking hands, putting a friendly face on the UAS mission. We talked to them, oh, when are you leaving? We're going to be leaving this time. We would deconflict our flight schedules so we could intentionally get out of their way. Again, back to the first point. 2020, the mission was boring, and boring is good in unmanned aviation. Cannot say that enough. The AI and the system reliability has allowed us to go with different data collection techniques. So now that we have GPS triggering on the camera, we don't need to have overlap on the pictures, so we can have fewer pictures covering the same amount of acreage out there on the water. And we're also at a bit of a ceiling. If we want a higher pixel camera, then it's going to be a very large step in price. If we want to be able to get the images out of the camera over a satellite link, the full-scale images, that's going to be a large step up in the satellite modem costs. So we're kind of at a step or a level off in price, because if we want any more capability out of the payload of the aircraft, it's a large step ahead from here. Also bears mentioning that in all of these missions, the preparation time takes months. So we went to Gas Bay in August of 2020, and the airspace approvals and submission packets and so on and so forth were being assembled and submitted in January and February. We're looking at 5, 6, 7 month lead time to get these missions off the ground. That is not a sustainable paradigm for UAS operations to cohabitate the airspace with manned operations. They don't need to put in paperwork half a year ahead of time just to fly. We do, which also means we get greater scrutiny. They sometimes forget that. So we can say right now that it looks like we're going back to Gas Bay in July and August. The flight approvals and authorizations have already been submitted. It's February. We're talking about flying in July. We've already got the paperwork in the system to get approved. Think about that for lead time processing, the logistics perspective. Another change. We have proven that the AI is reliable. So now that we've done that, we no longer have the requirement that we must manually review all of these thousands of pictures with an MMO, which gets us down to the truly in-flight decision making. So as the aircraft is on its way home, we can look at all the chips and say, no North Atlantic right whales today, we're good. And that can be transmitted to the Ocean Protection Program. The decision-making process accelerates. We are undergoing another round of mild refinement system, always striving for continuous improvement. So we're going to go with relocating a couple of components, striving for more reliability on the payload. So that boils down to a question. What is the mission here? Is the mission here to integrate into the airspace, or is the mission here to do the Save the Whales mission? If it's just save the whales, then segregating the aircraft off of an airport into a field in the middle of nowhere makes a lot of sense. But it doesn't help the integration and public acceptance and understanding of UAS to push them into the corner of a field and say, go fly out over the ocean, no one ever wants to hear from you again. Being at an airport has benefits. UAS could be a long-term part of the North Atlantic right whale mission and even the National Aerial Surveillance Program. That's what Transport Canada wants to do with them, and this is proving that. The growth of our approach with artificial intelligence and the camera is potentially spreading to other countries. So Canada's doing it right now. NOAA could be doing it in the US, and other foreign countries could be doing this as well. And the application here where you've got a camera taking stills running through a software algorithm in flight has applications outside of a particular endangered whale in a particular region of the ocean. We've done beluga whale surveys in other parts, and that's just two kinds of whales. There's all other kinds of marine mammals that this could be done with, and other kinds of over land missions that the same technologies could be applied towards. Hand it back off to the audience. Thank you very much.